Hello and welcome to today's tutorial. To get a PDF version of this tutorial, join our community on Patreon at patreon.com/ArielCad3D. You'll get access to our starter pack files, blueprints, transcripts, early access to our content, as well as native CAD files. You also get master course lessons that are available at our flexible tiers. So click the link in the description box below and you can join as a free member or any tiers that suit your needs. Let's learn how to create the I-beam axle. So this is a solid I-beam axle. It's called an I-beam because if you look closely, I don't know if I can zoom in, at the end, we've got a cylindrical eye. It's kind of like a line, and then an eye. It's like a capital I. So this is a solid I-beam axle. It's kind of hollow inside and it's got a section here where the leaf springs kind of pass through. So we are kind of using that suspension system to connect this solid axle with the frame and then the wheels. Okay, so we are connecting them through the suspension system and also the friction dampers so that we don't, we can damp off all those torsional and longitudinal and horizontal loads. Anyway, let me show you a picture. The closest picture I can find. So this is actually for a 1932 model, but it's exactly the same as the 1928 model. And right here you can see it's completely solid, like throughout, even where there's a section where we've got the leaf springs passing through, and these ports right here are where we are connecting the friction dampers. And then at the end, where we've got that one eye, this is a hollow part where the kingpin goes through, and this connects it to the stab axle. So this stab axle, there is an axle inside here where this one is gliding over. I know it seems like this is fixed, but actually these are rotating part. This is a wheel hub. It's a splined hub, and we are going to create this in the wheel assembly. Please check it out on my Patreon page. We are on lesson 3. We've already created the rim, the lacing pattern. We are on to the hub now in the wheel center. So kindly check that one out. And so we've got a stab axle inside here. I will show you what it looks like. So we try to create this as periodically correct as possible. And this arm you see here is actually a steering arm. For those periods, we had a steering arm, and there is one on this side as well. You see it, and then it's connected together by a track rod, and that's what controls, the steering left to right. All right, let's just go straight to it. We start with this section here because we've got to make sure that this width fits exactly that width of the leaf springs that we created. All right. So good thing we've got the blueprint, and the first thing we're going to create is of course the reference frame. You can see that the wheels are kind of tilted at an angle. So our stab axle will align with this horizontal axis, and also we use the side profile to map exactly where the stab axle is. Let's start with the side profile. So the stab axle obviously connects to the center of the wheel. So even though you can't see it here, you know that it's going to connect to this wheel, and this is the center part of the kingpin of the wheel hub, I mean. So we'll create our part first and foremost. We've got part 1, the ladder frame, part 2, the leaf springs. Now we will insert a new part to the chassis assembly, right? And do I want to define a new origin? No, I do not. I want to maintain the original origin because we are using a blueprint. So it's kind of important to keep things relative to how they appear in the blueprint, even though we are going to use constraints to set them up later on. And as usual, we can name it, and we'll call this the front axle or the solid I-beam axle. Now let me name it here. This is the solid I-beam axle. Because the back one or the rear one is not the same as this one, so you kind of don't need to name it that is the front one. All right, then we double click on this. We're going to design. There are two ways we can do this, because you know the solid I-beam is kind of can be irregular for the cross section. Like sometimes it's not exactly the same diameter, and it's connected, you know, maybe through welding and stuff like that. So you can use freestyle to create that shape connecting from the regular parts to the irregular, but in this case we're going to use part design. We will use the part design workbench. So perhaps I can switch from, this is GSD. I just go to the part design workbench. If you haven't created those shortcuts, just go to start mechanical design, select part design. It will redirect you to the part design workbench. Okay, now we want to create a reference plane or an axis system at this center, and then we can use that, right? So I believe the best way to do that is first to create a point. And yeah, we can use coordinates to just make sure that we offset in what? The X direction and the Z direction. So this part right here, we can maybe start by trying 300, see how far that one will go. And this is the negative side. We're going on the negative side. Let me try 500. That's too much. So first I estimate, and then I use small increments to adjust it to exactly where I want to be. You can see my points here. So then I just use single clicks to map it onto that line until I'm satisfied that it's at the center. So that seems those two can work. That's much better. And then on the Z axis, again, we can try 400, but we want it at the center. Let's try 350. Let's bring it relatively close to where we want it to be. Perhaps lower just a wee bit. Yeah. So that is very, very, very close to the center. That will work. And once you've got your point, remember this point is at the center. See? It's at the center. Select OK. And then we insert an axis system here. We're going to have maybe a few axis systems, because at the stub axle, as I said, it's kind of slanted at a degree. We don't want to make it the current, and we want it at the default. Select OK. Where was that? Oh, sorry. Axis system 1, the origin is this point. Nice. I'm actually going to hide these planes. I prefer to use an axis system because it's easier to click on the origin on this point rather than when I'm using the planes. I can now hide that point. Now we know exactly where we've got the front axle, and where it ends, it actually meets the kingpin or the stub axle, right? And then if you go to the front view, Now you can determine how low this section is, each section of this. Okay, so as I said, we will start with this one, which is a kind of a rectangular profile. So we can sketch the ZY plane. Now, because when we were doing the leaf springs, we did not consider the front section, it might be a little bit misaligned, but that's not quite a big deal. So the first thing we'll do is to map out the top and the bottom part of the leaf springs. Okay, so we will project or intersect. We're going to use a intersect, and it's right here, intersect 3D elements. So we will intersect this face with this plane. Okay, and the bottom side as well. You can select either with, once again, the YZ plane. And now if you go back to the normal view and reframe back, you can now see that hole. This, the one that is supposed to be this one, in this case it's kind of upper and a bit to the side. That's not a problem. What we'll just do is move this section towards this side and make sure it covers also the upper part. So just adjust it a little bit. Okay, all right, so as a matter of fact, we can close this using a line, and it's going to form the hollow part. Let me zoom in. So that's the inner part, and the outer part, I'm going to create a rectangle. Or I can just use a line. Hold on. Yeah, no, let's just create a rectangle like that. I will create an axis. And this axis is supposed to be symmetrical to these vertical lines. So I select those two and the axis, select symmetry. Note that I start with the lines and then the parts that I want to make symmetrical about those lines. Then for this is supposed to be about 70. And we've got the height to be about 75. So as you can see, that's quite an adjustment. The width and the height is the same as this one, but now instead of it being at this position, it's kind of lifted towards this direction. So you can choose to move the entire structure. So this one will also be lifted a little bit, or you can choose to keep the structures where they are and instead make this larger so that it can accommodate this profile. But in that case, it's not going to be centered as it is in this case. So my suggestion is we move it upwards. We move it upwards a little bit. It's not a problem at all. We can also make this maybe add about 10 millimeters to the width, and maybe, oh sorry, I just added 10, should be 80. We can make it wider, and instead of 75, we can have 85, so that we don't have to move our structure a lot. Let's see. You know, I'm thinking I can keep this top part the same. I can create the distance between these two sections constant and just increase the bottom side. Let's say make this to 90. Let's see, 90. Yeah, I think, or 95. I think that's the best solution. This is all about the creative process. This is all about, you know, making compromises and improves as you go along to make sure your product mimics the original one as much as possible and it serves the purpose. Plus, this metal is hollow, so there's not much significant addition of material or weight to when we make this from 75 to 95, so that we can keep this positioning kind of relatively the same. So this is where the leaf springs are going to pass. I can just keep it exactly as it is, so it's compact, the whole. For this part, we've got corners. You can add them later on using fillets, or I can just, you know, just put add them on right now. I can just select the 4 corners. So it should be rounded. It's going to add the same amount of corner to all 4 sections. Yeah, I think that's good. So that's a compromise that we've made, just a slight movement to this side, but it doesn't matter because it's going to be balanced on both sections. Okay, it's going to be balanced. That's our first section. We can exit and create a pad. So this pad is going to be guided by the diameter of this section, which I think it's about 300 millimeters, but I will confirm. So as you can see, it kind of drops where the width is kind of the same as the diameter of this section. Okay, but it can be slightly bigger because obviously we've got a fillet here that is making these 2 sections blend in together. Yeah, it's kind of bigger in terms of the thickness. The heightness, obviously it's bigger. So if this is 300, if we are going with this as 300, we can make it 400. And that is to the front and to the back. So it's 200 on each side because we are sketching at the center. Remember that. So we create a pad. And we want to select mirrored extent. And 200, we will come back and adjust. 200 is too much. 200 is definitely too much. Perhaps 300 is the diameter. Oh yeah, 300 is the diameter. Oh, that's a lot. That's a lot. Let me keep it 100 and then I confirm the diameter of that section. Definitely not. Should be about 100 probably in total. So that's still too large. It should be, sorry, not 300. I believe it's about 100. So that makes the radius to be 50. Pardon my mistake. Yeah, that seems reasonable. And we'll just confirm with you here by going to the front view, and we can measure, we can sketch ZY plane and create a line that is 50. Yeah, it seems the diameter is 50, not even 100. It's 50. I don't know. I think 300 is the length. I had checked earlier. I think it's the length of this pipe. So that's about 50. Then that's 25. So that if that's 50, then we should make our length about 70, not even 100. So I will undo that and exit. Sorry. And exit. Then go back to pad 1. My voice is breaking. I apologize. My voice is kind of breaking. So I want this to be, if I want it to be 70 or 80, then this should be 40. Okay. We will definitely mirror that to the other directions when we are done. The next thing I'm going to create is this section. And it's actually, sorry. Pardon me, I'll come back. So I was saying we need to create this cylindrical part. I can sketch the top view. I will make, let me first measure the diameter. I'll assume this is half of it. So perhaps it's from this position to about this position. So it's about 30. The outside diameter is about 30. Undo that, undo. I feel like I should create a point at this section to assist me, you know, with the positioning so that I don't struggle a lot. Point on plane, on the YZ plane, and I'll just position it here, and I'll say that the center of my kingpin, right? And I can create a plane. Select XY plane. Sketching is kind of easier with reference planes, so that I'll know that now I'm creating a circle and I want to make its center coincident with that point. Give it a diameter. Don't know if you can see. Give it a diameter of 30. And inside 20. So that means the kingpin diameter should be 20 millimeters. Then that will make it easy for me to extrude that sketch downwards. Does it go all the way down here or up to this position? I think this goes only up to this position, because we've got now the other feature here that contains the stub axle. The hub of the stub axle is the one that has the steering arm and all that. So that's about 70 millimeters. Great. Now we've got this part, All we need is a cylindrical part here, joining up to this section, and another one from here, joining up to this section. So for this part, because it's not very uniform, it's not something that you can just connect directly and then add. Maybe perhaps we can make a corner like that. It goes like this, straight, and then straight, and then straight, and then this one we make a fillet. But now the question is, if this is 30 millimeters, what is the diameter of this section? So we can see if it's going to fit here. So I will select the ZY plane. I know this is kind of tedious, but I want you to get a feel of if you are designing this as an engineer, you are reverse designing. You have to ask yourself a couple of questions. I will try to make this perpendicular to this line, just an estimate. And I can see the diameter is about 40. So what I think I will do is on this plane here, I will create an oval shape so that the length is larger than the width, because the maximum width we can have here is 30. As a matter of fact, it should be less. It should be about 28 so that it can fit here. So we'll have 28, and what's this height? The height can be about 45 by 28. So this is 45 by 28. We've got a 40 section here and a 40 section joining here. Okay,